Okay, so our instruction in this problem is to solve for x. So here we have a lot of negative exponents, and my intuition tells me that if I can get rid of a negative exponent, I should. So what I do is I deal with this term right here. This is just equal to 1 over 3, or 1/3. And this just goes back to that basic principle with negative exponents, right? The basic guiding principle throughout this whole process is that if you take something like a, and you raise it to a negative power, like negative n or something, that equals 1 over this base a to the positive n. Essentially, taking something to the negative power gives you 1 over that base to the positive power. It reverses these things. And that's what's happening right here, right? The base is 3, it's to the negative 1, so that equals 1 over 3 to the positive 1, or just 1 over 3. And that might not seem helpful, but really you want to cut down on these negative exponents. And now if I rewrite everything, we might see our next step. Here this to the negative 1, and on this side again we have 3x to the negative 1 all over 1 plus x to the negative 1. My next step here, and there are lots of options, but I think it's easy to think about multiplying both sides by 3. So here's one term, this whole thing. Multiply it all by 3, and do the same on this side to keep it balanced. So what happens now? Well, here 3 divided by 3 is just 1. On this side, 3 times 3 is 9, right? So what do we get? Well, now what we get is 9x to the negative 1 over 1 plus x to the negative 1. And that's going to equal, now we've kind of cut this term down a little bit. All we have left, this is gone, is this term right here. And let's rewrite that, because this whole thing, you can think of that now as our a term in this relationship right here. Something to the negative power equals 1 over that something to a positive power. So in this case, this will end up equaling 1 over x to the negative 1 plus x to the negative 2. And all I did there was apply this exponent to the whole term. And that takes this whole thing and puts it in the denominator, right? And in fact, we're almost done. And I know it might not feel that way, but we're almost there. So the next step here, I'm going to move up here now. As I rewrite this, I'm gonna take a couple of things into account. I'm gonna work on the right side here. We have 1 over, and then 1 over x, and that's just x to the negative 1, rewriting that, plus 1 over x squared. And that's going to equal 9 times, and then this is, I think, let me just pull this apart here. This fraction, I'm going to pull it apart to think of it just for myself as this. 9x to the negative 1, that times 1 over 1 plus x to the negative 1. And all I did there was pull apart this fraction, right? If you think about how I'd multiply this back, I would end up multiplying 9x to the negative 1 times 1, and that would be over this, right? That's pretty common for multiplying fractions. We just multiply numerators and then leave denominator, or multiply denominators. If we multiply these two terms, we go right back to this. And the only reason I'm doing that is because it helps me deal with this next step. I would rewrite this as 9 times 1 over x, right, times 1 over 1 plus x to the negative first. And this just helps me look at the problem from a clearer perspective. Because, oh, and what I might want to do, I'm sorry, I'm going to rewrite this bottom as 1 plus 1 over x. And now I'm really almost there, right? Because what's going to happen is, if I multiply everything on this denominator over here by x, or x squared, that's going to be really helpful. But I can't just multiply something by x squared. That'll change the number. So what I have to do is keep it balanced. I'm going to multiply both numerator and denominator by x squared. That's my key step in solving this problem. And if you remember what's happening there, all we're doing is taking a fraction and multiplying it by 1. X squared divided by x squared is still just 1. So for example, with 2/3, if I wanted to rescale that, I can multiply 2 and 3 by any number. Let's say by 3. or by 4. But if I multiply a numerator by 4, I also need to do it in the denominator. This is a key idea, right? 4 over 4 is just 1. So as long as I multiply a fraction, in this case I would get 8 over 12, that's still 2/3. Nothing has changed. Because I multiplied everything by 1. 4 over 4 is 1. And that's the key idea I'm using right here. Here I'm multiplying by x squared over x squared, which is essentially 1. Now what will happen when I do that? Well, in the numerator I'll get x squared, right? 1 times x squared is just x squared. But in the denominator, what's going to happen is things will start to cancel out. Here we have 1 over x times x squared. And what's that? Well, that's just x, right? Because x squared divided by x is x. Plus 1 over x squared times x squared. And that's just 1, right? Because here, x squared divided by x squared is 1. Now on this side of the equation, right, what are we going to do? Well, if you think about what happened when we wrote this, ultimately it's going to happen now. If I kind of redistribute, I'll get 9 times 1 over x times 1 over 1 plus 1 over x. And all I'm doing is using the associative property to regroup. 9 times 1 over x, this x here is in the denominator. So I'm pulling those fractions apart. And now when I multiply these two, I'm basically done. Because x times this, I'm going to use the distributive property. X times 1 is x. X times 1 over x is just 1, right? Because it's x divided by x. And then on the numerators, I have 9 times 1 times 1, or 9. And now, maybe you see it, we're basically done. And this is so cool, right? What's happening here? Well, now what we're saying is 9 over x plus 1 is equal to x squared over x plus 1. And what that means, of course, is that x squared is equal to 9. And all I'm saying there is, if you imagine 9 over x plus 1 is equal to something else over the same number, that means these two numerators have to be equal, right? They're both over x plus 1. And since they're equal fractions, whatever's up here must be equal. And if that's not obvious to us, multiply both sides by x plus 1, right, here and here. And now what happens, right, x plus 1 over x plus 1 cancels out. X plus 1 over x plus 1 cancels out. And there you see it now, right? X squared equals 9. So what does x equal? We'll take the square root of both sides, and x is going to be equal to positive or negative 3. Right, because negative 3 squared is 9, and so is positive 3. And in this case, I would say that's what x equals. And just to kind of recap what happened here, I just kept manipulating the negative exponents until I was able to cancel out. And you got to really hang in there and not be afraid to pull this stuff apart and play with it until you get something that looks friendly and usable. But believe it or not, all this nasty stuff, all you got to hold on to is this idea right here, and you'll be just fine. All right, thanks a lot.